In the study of chemistry, the most fundamental starting point is the atom. Understanding atoms, ions, and molecules is where real chemistry begins. These are the units that make up everything from the air you breathe to the DNA in your cells. For students tackling general or AP chemistry, getting comfortable with these concepts is essential. For section 1, we have why atoms, ions, and molecules are foundational to chemistry. Atoms, ions, and molecules form the building blocks of all matter. Atoms are the smallest units of an element that still retain the chemical properties of that element. When we understand atomic structure, protons, neutrons, and electrons, we begin to understand why elements behave the way they do in chemical reactions. Ions are atoms or groups of atoms that have gained or lost electrons, resulting in a net charge. This is key for understanding how compounds form, how electricity flows in solutions, and how acid-base reactions happen. Molecules are stable combinations of two or more atoms held together by chemical bonds. When we talk about molecules, we get into bonding theory, shapes of molecules, and the difference between ionic and covalent compounds. The better you understand atoms, ions, and molecules, the easier it is to connect the microscopic structure of matter with its macroscopic properties, something you'll see over and over in chemistry. For section 2, we have the atom, the basic unit of matter. An atom is the smallest unit of an element that retains its chemical identity. Even though atoms are extremely tiny, and we're talking like picometers, each has a complex internal structure that influences how it reacts. Atoms are made of 3 key subatomic particles. Protons, or P+, are positively charged and located in the nucleus. The number of protons is the atomic number, and it defines what an element is. We can think of the atomic number as basically the jersey in basketball for that atom. It's always going to tell us what atom we have, and the identity will not change. For neutrons, or N0, these are neutral particles also located in the nucleus. They add mass and influence the stability of isotopes. Electrons, or E-, are negatively charged and found in orbitals outside the nucleus. How these are arranged determines the chemical properties of the atom. In a neutral atom, the number of protons equals the number of electrons. For section 3, we have atomic number and mass number. These are 2 numbers to know for every atom. Atomic number, or Z, is the number of protons in the nucleus. This is unique to each element. For example, hydrogen has 1 proton, so its atomic number is 1, and carbon has 6. On the periodic table, the atomic number is the top number for all elements. And then we have the mass number, or capital A. This is the total number of protons plus neutrons. And we have an equation to help. Mass number will equal the atomic number plus the number of neutrons. And the atomic number is also known as the number of protons. This becomes really important when we talk about isotopes, and isotopes are atoms of the same element with a different number of neutrons. For example, carbon-12 and carbon-14 are isotopes because they are both carbon with 6 protons, but carbon-12 has 6 neutrons and carbon-14 has 8 neutrons. Both are carbon, but 14C is radioactive and behaves differently due to the different number of neutrons that it has. For problem 1, we have how many protons, neutrons, and electrons are in a neutral atom of 40 Ca. First, we can determine the number of protons from the atomic number on the periodic table. The top number on the periodic table for Ca is 20, so calcium has 20 protons. When they only give us one number in a problem, like the 40 here for 40 Ca, this will always be the mass number, and it will also always be at the top of the chemical symbol. A chemical symbol will have the atomic number at the bottom, the mass number at the top, the element symbol, and the charge at the top right. If there isn't a charge though, they won't give you a value at the top right. We'll just know that the number of protons equals the number of electrons because the positive and negative charge are balancing each other out. Using the atomic number and the mass number, we can find the number of neutrons. I'm going to subtract 40 from 20 to get 20 neutrons. And because the atom is neutral, the number of protons equals the number of electrons. So we're going to have 20 electrons. Overall, 40 calcium has 20 protons, 20 neutrons, and 20 electrons. Section 4 has the formation of ions. So now let's talk about what happens when atoms gain or lose electrons. Atoms are usually neutral, meaning they have the same number of protons and electrons. But if they lose or gain electrons, they become ions. A cation is an atom that loses electrons and becomes positively charged. An anion is an atom that gains electrons and becomes negatively charged. For example, sodium has 11 protons and 11 electrons. If it loses one electron, it now has 11 protons and 10 electrons. There's also an equation we can use to calculate the charge. Charge will equal the number of protons minus the number of electrons. So 11 minus 10 will be a positive 1 charge for Na. And to show that charge, I'm going to put a +1 or just plus at the top right of the element symbol. Another example is chlorine. Chlorine has 17 protons and 17 electrons. If it gains 1 electron, it now has 17 protons and 18 electrons. 17 minus 18 will equal a -1 charge, so I'm going to put a minus at the top right, so we'll have Cl minus or Cl minus 1. Creating ions or elements with charges will not change the number of protons because this is still the element's identity, but we will change the number of electrons when the charge changes. In summary, cations form when electrons are lost, more protons and electrons equal a positive charge, and anions form when electrons are gained. More electrons and protons equal a negative charge. Ions are essential to ionic bonding, and they come up constantly in both inorganic chemistry and biochemistry.